Hello children, today we are going to discuss chapter Atoms and Molecules. Atom is the smallest particle of matter which can be further broken down into more smaller parts. That was the first definition of atom. In Dalton's atomic theory, we also discussed the same thing, that atom can be further divided into more smaller parts. Atom may or may not have independent existence. So atoms combines to form molecules to attain stability. First thing is laws of chemical combination. First is law of conservation of mass. Law of conservation of mass states that in a chemical reaction, mass always remains conserved. Means mass of reactant will always be equal to mass of product. To demonstrate this activity, here we are having reaction of sodium sulfate with barium chloride. What we have to do, we are taking here barium chloride and we are reacting it with sodium sulfate. This is example of double displacement reaction. Here we are taking fixed amount of barium chloride and sodium sulfate. Sodium will combine with barium. Sodium will combine with chlorine to form sodium chloride. And barium will combine with sulfate to form barium sulfate, which will settle as white precipitate. This is an example of double displacement reaction. Here we have to prove law of conservation of mass. How we will do this? We are taking a conical flask here. In conical flask, we are taking sodium sulfate solution. Then we are taking ignition tube. In ignition tube, we are taking barium chloride solution. So we are putting this ignition tube inside the conical flask and it is tied with the thread. And that thread is fixed in the cork. When you will stretch the thread, this ignition tube will get mixed with the solution of sodium sulfate. So they both will combine and reaction will take place. We will notice that mass of reactant will be equal to mass of product in this case. So it holds law of conservation of mass good. This reaction we are doing because it is not having any kind of gaseous reactant or product. It is not easy to do this reaction with gaseous reactant or gaseous product because it would be tough for you to calculate the mass in that case. Second, we are having law of constant proportion. Law of constant proportion states that in a chemical compound, elements always combines in definite ratio by mass. Say you are having water. Water is having ratio of hydrogen is to oxygen as 1:8. So if you are taking 9 grams of water, it is having 1 gram of hydrogen which is combines with 8 grams of oxygen. So it is forming 9 grams of water in that way. This ratio will be fixed irrespective of the source from where you are taking it. You can take river water, you can take water from canal, from India or Australia. This ratio will not change. It will always remain fixed, 1:8. Then you are having postulates of Dalton's atomic theory. Dalton's atomic theory states that matter is made up of very tiny particles. They are called as atoms. Atoms are indivisible. They can't be further broken down into more smaller parts. You can't create or destroy atom in a chemical reaction. But my dear children, we have to notice that today in modern atomic theory, we explain it like this. Atom can be divided into further electrons, protons, neutrons. As these subatomic particles are residing inside the atom, so they are smaller than atom, of course. So we can say atom can be further broken down into electrons, protons, neutrons. Then further it was given that atom can be created or destroyed. But when we look into the case of reactions, like you are having nuclear reaction, say we are having Suppose nuclear fusion. In nuclear fusion, you are having two atoms of deuterium. They are combined to form one atom of helium. This is nuclear fusion reaction. Here we are taking two atoms of hydrogen, second isotope of hydrogen, deuterium it is, they are combined to form helium. So new atom is formed, old atoms are destroyed. So this is example where you can say that atom can be created or destroyed. If you are taking uranium, you are having uranium 92 to 35. When it is bombarded with neutron, it is again giving you barium, krypton, and 3 neutrons. So again in this example, you can say atom of uranium is destroyed and barium and krypton are formed. So this is again violating the same rule that it was saying that atom can't be created or destroyed, but here atom can be created or destroyed. Then atoms of given elements are similar in mass and properties. We know that if you are taking atoms of same type, they would be same in their mass and in their properties. But here if you are having example of isotopes, isotopes are atoms of same element having same atomic number but different mass number. Say you are having here three isotopes of hydrogen, protium, deuterium, and tritium. These three are having same atomic number, but their mass number is different. As their mass number is different, so we can say their very basic property, atomic mass is different. So again, see this rule, it was saying that similar atoms should have similar mass and properties, but this is exception to this rule. Then if you are saying atoms of different elements have different masses and different properties, then comes the case of isobars. Isobars are atoms of different elements having different atomic number but same mass number. Like you are having here argon and calcium. Both are having different atomic numbers. Argon is having atomic number 18, mass number 40. Calcium is having atomic number 20, mass number 40. So these are atoms of different elements having different atomic number but same mass number. Atoms combines in whole number ratios to form compounds. This should be simple whole number ratio. Atoms may combine in a ratio which may not be small simple whole number ratio. Like if you are taking sucrose, sucrose is C12H22O11. Ratio of masses of these elements is not simple whole number ratio, right? So this is also exception to this rule. In a compound, atoms are present in relatively fixed amount. Like in water, H2O. Two atoms of hydrogen are combined with one atom of oxygen. This ratio will remain fixed. So what I have explained now is modern atomic theory. In Dalton's atomic theory, we need certain modifications that I have explained now. What is atom? Atom is smallest particle of element that may or may not have independent existence. Its size is very small. It is in the range of nanometers. Nanometer means 10 is to power minus 9 meter. It is such a small thing that is beyond your imagination, that you can't see with your naked eye. Then comes the concept of atomic mass. Here I want to give you one example. Say if you are going to vegetable market and you are going to a shop to buy certain things, like you want to buy mangoes, say, and the shopkeeper is not having any measuring device at that time. So what he can do? What could be the option, right? So the option is, like, suppose he is having one big watermelon which is having weight 12 kg. So he'll go to some neighborhood shop, and that watermelon will be divided into 12 equal pieces, right? So one piece will now weigh 1 kg. So on one side of his measuring device, that takdi, he will keep that piece of watermelon. On another side, he will start keeping the mangoes. So he will measure the weight in comparison to that piece of watermelon. That is called relative atomic mass. It is not actual mass, it is measuring the relative mass. Similarly, here in chemistry, we are having standard element carbon. Carbon is taken as reference element. Its mass is 12 unit, and 1/12 of that mass of carbon will be considered as 1 unit. That was initially called 1 AMU. 1 AMU means 1 atomic mass unit. Nowadays it is called 12 U. U means unified unit. U is universal value which is used all over the world with the same thing. Right? When you want to measure the mass of any substance in comparison to carbon, that will be called as atomic mass. Say you want to measure the mass of oxygen atom. What we will do? We will keep oxygen atoms on one side and carbon atoms on another side. Say if you are saying that you have kept 3 atoms of oxygen and you have kept 4 atoms of carbon and their mass is coming same. Actually, we can't keep 3 atoms or 4 atoms. We will take 3 lakhs, 4 lakhs, like that. Okay, this is just an imaginary thing. So if you are taking 3 atoms of oxygen on one side and 4 atoms of carbon on another side, and their weight is coming out to be same. So what should be the mass of oxygen? We can calculate mass of oxygen from this calculation in this way. You are having, say, oxygen is having mass X, and carbon atom, you know that mass is 12. 4 atoms of carbon are coming equal to 3 atoms of oxygen. So it will give you oxygen is equal to 48 upon 3, that is 16 unit. From there, you can calculate the mass of oxygen atom. In this way, we have calculated mass of different elements, and these values are given here. Then comes what is molecule. Molecule is formed when different elements are combined to attain stability. Atoms combines to form molecules so that they can attain a stable structure. Molecule always have independent existence, and a number of atoms can join to form molecule, right? That is called its molecularity. How many atoms are combined to form molecule? That is called its atomicity. Atomicity means how many atoms of particular type are combined to form a particular molecule. Like we are having different examples. We can have monoatomic. Mono means single, which is having independent existence. Like we are having noble gases, we are having argon, we are having helium. They are having atomicity 1. They are monoatomic. Then we can have diatomic. Di means 2, where 2 atoms are combined to form molecule. Like oxygen, hydrogen, nitrogen, chlorine, these are diatomic gases. Then you can have triatomic. Tri means 3, where 3 atoms will be combined. Like ozone, O3. Then you can have tetraatomic. Tetra means 4, where 4 atoms are joined together, like phosphorus, P4. Then poly. Poly means many, where different atoms are combined, more than 4. Like you are having here acid, polyatomic molecule. Then these are all examples of homoatomic molecule. Homo means same, where same type of atoms are joined. If different types of atoms are joined, that type of molecules will be called heteroatomic molecule. Like in dye, you can have example HCl. In tri, you can have example CO2. Tri means 3. In tetra, you can have example H2O2, hydrogen peroxide. In poly, you can have example like nitric acid, sulfuric acid, phosphoric acid. If an exam question will be there, find the atomicity of nitric acid. How you will find? 1 plus 1, 2, 2 plus 3, 5. So it is having atomicity 5. These are molecules of compounds. Like water, water is having hydrogen and oxygen. 2 atoms of hydrogen, 1 atom of oxygen. They are combined, so atomicity is 3. Then we have ions. Ions means compounds of metals or non-metals which are having certain charge on them. If they are having positive charge, it is called cation. If it is having negative charge, they are called anion. First 20 elements we know that how to write their valency, how to write their symbols. If you don't know, you can revise with me. There's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. We can write in this way: hydrogen, helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. For finding their valencies, we need to write their configuration. 1, 2. Lithium is 3. 3 means 2, 1. 2 electrons will go in first shell and 1 electron will go in second shell. Then 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Those which are having 1 electron in outermost shell, like hydrogen, lithium, they will have valency of +1. After that will come like sodium. Sodium will be 281. Then comes potassium. Potassium will be 2, 8, 8, 1. So they are all having 1 electron in outermost shell. This group will have valency of +1. Second group, they are having valency of +2. Third group, they are having valency of +3. Then carbon family, they are having 4 electrons in outermost shell. By convention, their valency is written ±4. Actually, this group has tendency to share electrons. They don't lose or gain electrons, but by convention, we are writing as ±4. Nitrogen family, it is having valency of -3 as they are having 5 electrons in outermost shell. They are having tendency to gain 3 electrons. Oxygen family, they are having valency of -2 as they want to gain 2 electrons to complete their octet. This fluorine family, halogens, they are having valency of -1. They want to gain 1 electron. Helium, neon, well, they are having valency of 0, means they don't want to gain or lose electron. Right? So first 20 elements can be written in this way and you can calculate their valency. And for polyatomic ions, you need to learn their formulas. Then you will be able to write their chemical formula and their structure. Like if you have to write, say, formula of calcium oxide, how you will write? First, you will write symbol of calcium, then oxygen, then you will write their valencies, then crisscross. This valency will come with this valency will come with this. So it will form Ca2O2. 2 will cancel, it will form CaO. If you are having aluminium oxide, aluminium 3 positive, oxygen 2 negative, crisscross, it will come with it, it will form Al2O3. Its valency will be written with it. So valency of oxygen is 2, it is written as subscript with aluminium. So it will form Al2O3. Then comes to molecular mass. Molecular mass means you have to add up the mass of different atoms. Like you are having H2O. It is mass of hydrogen is 1. So 2 atoms of hydrogen makes 2 plus 16. So it will give you 18 units. That would be mass of one formula of water will be 18.